Hello friends, in today's question, block A has a mass 40 kg and B has mass 15 kg and F 500 Newton parallel to smooth inclined plane. The system is moving together. We have to find two things. The acceleration of the system is the least coefficient of friction between A and B. So we have two blocks. B is on the top of A and there is a friction between B and A. Force F is being applied along the inclined plane and there is no friction between A and the inclined plane. Okay. So it is said that the system is moving together. Okay. So we say let A be the common acceleration of the blocks A and B. So under this condition, let us draw the free body diagram for them. So they are moving together. So this will be A plus B, and a force, that is F, is being applied, which is along the inclined plane, up the inclined plane. So in the downward direction, we are going to have MA plus MB multiplied by G, and which can be divided into two components. So this will be 30. Along this, we are going to have MA plus MB G cos of 30, and in this direction we are going to have MA plus MB G sine of 30, and it is moving up the inclined plane with the acceleration A. So based on this, we can write the equation as F minus MA plus MB G sine of 30 is equal to MA plus MB multiplied by acceleration A. So this is the equation of the motion when the combined block A and B, A plus B, are moving together up the inclined plane. So from here we can write that the acceleration A will be equal to F minus MA plus MB G sine of 30 divided by MA plus MB. Substitute the values. You can write this as acceleration A, F is 500 Newton, minus MA is given as 40, MB is 15, G is 10, and we have here sine of 30, and divided by 40 plus 15. So this will become equal to as 500 minus 275 divided by 55. So we can say that the acceleration A will be equal to, this will be coming 45 divided by 11 meter per second square. So this is the acceleration of the system. This is the acceleration of system, which is block A and B. Now we are going to find out the coefficient of friction between A and B. So it said that both of them are moving together. Let us deal with part B. So part B, you can say for block B, this is our block B, and in the downward direction we have BG, in the upward there is a normal NB, and the frictional force will be FR, and this is also moving, you can say, with the acceleration A along the inclined plane. Let me draw it here. So this will be acceleration A. This can be divided into two components. This will be 30. So this component we are going to get as A cos of 30, and this will be A sine of 30. Okay. So this is our nothing but B. So we can write that the maximum value of the friction for block B, maximum value of friction, let us call that as FR max, which will be equal to coefficient of friction, let us say that is mu, and multiply by NB. And for NB, we can write the equation as it is moving in upward direction, so we are going to have NB minus MBG. This will be equal to MB multiplied by A sine of theta. So this is the equation for the motion for block B. From here we can write that our NB will be equal to MBA sine of 30 plus MBG. We substitute the values and we can say that our NB is given as 15 kg. 15 acceleration A is our 45 by 11, and we have sine of 30, that is 1 by 2, plus MB is 15, and that is multiplied by G is 10. So you can say that our NB will be equal to this will be 265 multiplied by 15 divided by 22. So we can say that our frictional force Fr max will be equal to mu multiplied by 265 into 15 divided by 22. This is the value of the maximum friction. Now we are going to find out what will be the value of the friction when the block B is with acceleration 45 by 11. Okay. For the acceleration A, which is given as 45 by 11, the actual value of the friction. Let us call that Fr. So we can find out that our Fr by this equation we can say that our Fr will be equal to the acceleration, that is mass mb multiplied by a cos of theta. So we get this as mb a cos of 30. We substitute the values. MB is our 15 and A is our 45 by 11 and cos of 30 is root 3 by 2. Now it is said that both are moving together, okay, but blocks B and A are moving together. So which basically means there is no slipping between B and A. Thus, no slipping between block B and block A. So under this condition, the friction Fr, therefore friction Fr will be less than equal to Fr max. We substitute the values of Fr as well as Fr max. So Fr is our 15 multiplied by 45 by 11 and this will be our root 3 by 2 and our Fr max is mu 265 into 15 by 22. So we write this as mu 265 into 15 divided by 22. So 15, 15, 11, 2, this goes away and we are left with mu is equal to 45 root 3 divided by 265 and we can cancel it through 5. This will be 9 and this will be 5 and 3. Okay. So we can say that mu is equal to 9 square root 3 divided by 53. So this is the value of the least coefficient friction between A and B. Okay. You can say, let me write here, for least mu this should be equal. So from here we can say, thus this is the least value of friction between blocks A and block B. So this completes the question. Thank you.